We show a gaze-based command activation technique that is robust against unintentional activations using a dwell-then gesture. In a gaze-based interaction, preventing an unintentional manipulation is a challenge, because it is difficult to distinguish whether this user moved the gaze for activating a command or not. For example, a gaze movement occurs in every human activity, such as reading a sentence or watching a movie. To address this challenge, we carefully designed the detection system of dwell-then gesture experimentally. With our technique, object selection is performed by dwell and then, a command related to gaze movement is activated by two-level gaze movement. In this case, a right then up stroke activates a command on an object that the user dwells on. We show application scenarios of our technique. Considering the file manipulation, the user may want to copy an image and paste it in the folder. The user first copies the image, opens the folder, and pastes the image in the folder. A switching of the window is activated by an up then right gesture. If the user's dwell has been detected on an object, a command is activated on the object, for example, opening a file or copying an icon. If the user's dwell has been detected outside an object, a command for the whole window is activated, for example, switching the foreground window, moving the next page, or pasting the copied object. To prevent an unintentional command activation, we adopt 4 parameters. The first is the dwell time used for dwell detection. Users need to keep looking at an object for this amount of time to select it. The second is the width of a path to allow a zigzag gaze movement. Users need to move their gaze inside the path. The third is the threshold of distance users should move their gaze in the horizontal or vertical direction. The last is the range of time taken for a stroke. Users need to finish performing a 2-level stroke within this range. To determine these parameters, we conducted an experiment. During the experiment, the participants were asked to perform 3 tasks. In total, we obtained the participants' gaze trajectories for 272 minutes of gaze-based manipulation. During the task, the participants manipulated the applications using a dwell-based target selection. Using the gaze trajectories, we determined the parameters through a simulation. As a result, we derived the combination of parameters which achieves 0 unintentional command activation. We show the process of dwell-then gesture detection with the determined parameters. In this part, real parameters are used. When a 552 milliseconds of dwell are detected, an invisible path is generated. When the gaze moves 116 millimeters to the right, a right gaze movement is detected. After the right movement is detected, when the gaze deviates from the path, an invisible path is generated. When the gaze moves 66.9 millimeters upward, the up gaze movement is detected. If the time taken for the stroke is within a specified range, the command related to a right then up stroke is activated. Next, we show the performance of our technique. The success rate of our technique is 85.8% in one attempt. The advantage of our technique is its robustness against unintentional manipulations, therefore, users can attempt again without considering an unintentional command activation. In this case, the success rate of our technique is 99%.